Welcome to our first lecture in Chapter 1 for College Algebra. Now, this section we're going to look at is going to be mostly a review section over concepts that you've seen in previous math courses. Now, we're going to be looking at the idea of functions, but before we get into functions, we're going to talk about relations. Now, before we get to that, let me remind you that when we're working with functions and relations, we usually have something called the independent variable and the dependent variable. And the independent variable is considered the input into some sort of rule, and the dependent variable is usually considered the output. Now, this is just one of these conventions in mathematics. Because a lot of our functions at this point are graphed on the xy plane, we have the coordinate pair xy, we call x the independent variable and y the dependent variable. And here, under the first example, are some examples of how you can relate things to each other. The first example talks about a letter grade, which is an output in some course, and it depends on the numerical average that is calculated in the grade book, which is x. So x, the numerical grade in the grade book, is the input, and once that's put in, the letter grade is figured out from some set of parameters. Another example is the amount of money paid for gas at a gas station, where y, right here, that is how much we're spending. That's the output of the function, how much we spend on it. And x is how many gallons of gas we put into the gas tank. The independent variable. We can decide when to stop pumping the gas. And wherever we decide to stop pumping the gas, the output is how much money we have to spend for it. Now, as I said, we usually use this format of xy, an ordered pair, to represent the related quantities that correspond with each other between input and output. So, for example, if you pump 5 gallons of gas, then let's just pick a nice easy number, $3 per gallon. If you pump 5 gallons of gas, your output would be $15 that you would have to pay for it. Now, here's our first definition. I've mentioned relation. A relation is a set of ordered pairs that comes from a rule of correspondence between two sets. So once again, the correspondence, that the gas and the money that you spend, how much gas you pump corresponds with how much money you're going to pay for that gas. Now, we have independent variables, and we put them in set D, and that D is there because that stands for domain. And then we have dependent variables, which they do take different names at this point for this thing, but that set of all possible values of y, whatever letter you put there, that is called the range. So the range goes with the output, it connects to the y values, and the domain goes with input, connects with the x values. Now, our definition said it's an ordered pair, but an ordered pair can be expressed numerous ways. In this particular section, we're going to look at it in 4 ways. We're going to look at it as ordered pairs. We're going to look at it as a table. Here's a table value. We're going to look at it as something called a mapping. That's where you have these diagrams that show you which input variables go with the output variables. And we're going to look at the relations as graphs, if we can. So, once again, domain is a set of all the values, the input values, and range is a set of all the y values. And then domain over there. Domain goes with x. Okay, so let's take a look at this relation that we're given here. We have a relation, and you're probably remembering at this point that somewhere in here we have a rule about something repeating. And you probably know it, as I said. We could be speaking it right now. But when we look at relations, we're not really interested in trying to determine what type of relation it is to start off with. What we need to look at right here is how the input maps to the output. So in this case, we have x1 x1, and it maps to two y values, y1 and y2. And that is shown by the arrows in this mapping of x1. It maps to y1. It corresponds to y1, and x1 corresponding to y2. So there's two arrows coming from x1 to the two values it corresponds to in the range. Now, as we go through here, we can see x2 also repeats into two values, and you can see those two arrows moving. And x4 has two values. So x4, there's the two values of x4 mapping off for y3 and y4. x4, y3. But you notice x3 only has one value in this list. x3 corresponds to y3. So if x3 corresponds to only one y value, it will only have one arrow, and this mapping shows that. Taking a look at the table, this is a little bit clunky, I will admit. It's very strange. But what this clunkiness is telling us is that we have a rule that we can plug our input values, our x values, into. And when we plug the rule in using function notation, we put the input value inside the parentheses, and we do whatever the rule is, and we get out the corresponding y value. So this table is showing us all of our inputs and all of our corresponding outputs that match up here to these ordered pairs. Now, if you take a look at this, if we had to figure out the domain is once again a set of all of the inputs. And I'm going to go down the table because it's the easiest for me to see. x1 was put into the function, or the relation, excuse me. x2 was put into the relation, x3 was put into the relation, x plus x4. So all four of these x values make up our domain. Our range is comprised of y1, right there, and then y2, y3, and then y4, separated by the x's, but there they are. It happens as well. And if you notice, our range is y1, y2, y3, y4. So we have our range. And there's a little star here, and it says, note that the value of y5 is not in the range of this relation. And the question is, why? Well, the reason it's not in the range is because it does not have a corresponding x value that maps to it. If you remember the previous math classes, you would have relations that you graphed, such as this one. Graph that beautiful circle. Hopefully you graphed that at some point in a previous math class, something like that. And this circle represented all of the x and y values that made the circle. And all of these y values out here, they had nothing to do with the range because they weren't used. And all of the x values down here had nothing to do with the domain because they were not used. The domain is a set of all of the inputs, and the range is a set of all of the associated or corresponding outputs. So we take a look at the next page. We have a few examples. And we have one where we have individuals taking courses, and they want the example wants us to set up the mapping and show how everything works out in this diagram. So Joe is taking algebra and English. Todd is taking sociology, and Matt is taking biology and English. Using these letters that are given to us up here, that's what I'm using. My domain is made up of their names. We have Joe, Todd, and Matt. And then Y, the range, or the possible range, let me see how it maps out, is algebra, biology, sociology, and English. So algebra, biology, sociology, and English. And it tells me that Joe is taking algebra and English. So two arrows from Joe to those two subjects. Todd is taking sociology, so one arrow sociology for Todd. And Matt is taking biology and English, so two arrows there. And that's the diagram of our relation. Now notice that every one of these x values maps to something in the y, and every one in the y maps to everything in the x. So the domain is made up of Joe, Todd, and Matt, as listed here. And the range is made up of algebra, biology, sociology, and English, all four of those subjects. Okay, so we're going to stop here on this video. We're going to pick up on the next video when we talk about a special type of relation known as a function.